Today my project is regarding skin cancer detection. As we all aware of that, skin cancer is one of the most common types of cancers worldwide. So the early detection of skin cancer will improve the survival rate and also the treatment outcomes. So the automated skin cancer detection by using a deep learning model will help for the assistance of many dermatologists and also increase the survival rates and also gives the accurate predictions. So the objective of this project is to develop a convolutional neural network model that will help to differentiate various skin lesions from different skin cancer images from the image data. So I have done this project. So first code refers to the mounting of our Google Drive to the Google Colab. So that command will help for the accessing of the complete files in our Google Drive account. So the next one is the data set. So I have taken the CNN assignment which contains the training data and the testing data from the canteen. So I have taken the dataset from ISIC, that is International Skin Imaging Collaboration, which contains various types of skin cancer images. So now we are importing the required library for doing our project. The first one is Mathlib and OS. These two libraries of the Python package will help for the handling of the file paths. Next one is NumPy and Pandas. NumPy and Pandas used for the numerical features and also for the visualizing of our model performance. And the next one is Fill, that is used for the loading images, nothing but the image processing in the dataset. And the next one is TensorFlow, that is the deep learning neural framework. And the next one is Keras, which contains many number of deep neural network layers. It is a high model after the TensorFlow. Next is Sequential, which contains the stacked and sequential pattern for the n number of neural network layers. And the next one is Adam, that is the optimization algorithm that is used for the deep learning. And the next one is model checkpoint. So model checkpoint is used in order to save the best model at the training phase. And the next one is early stopping. So when we get to know that the model is not performing or the performance has stopped, it will stop the training phase and gives the best model. And the next one is load image library, that is used for the loading the image files. We are defining the path by using pathlib.path for the training and the testing data which were in our CNN assignment folder. So we are defining the path like data directory train for the test data and the data directory test for the testing data. So now this code is used to count the number of images both in the training and the testing directories. So we contain total of 2239 training images and also 118 testing images which are in the format of JPG. So this code is used in order to visualize one sample from each class. So we have total 9 classes and found 2239 files, and we will be plotting each image from each class. In order to do this, we have used the code image underscore dataset. We are importing the images from the training space, and the batch size 32 is refers to we are grouping the images in the batch of 32, and image size 180, 180 refers to we are resizing the images in the form of 180 into 180 pixels, and the label mode is categorical, that means one hot encoding process for the multi-class classification. And the next one seed is equals to 123. This refers it ensures the same split consistently for accurate results. And now next command class names images underscore dataset refers to this will retrieve the unique skin cancer categories. And the next one is files path dictionary is to store the path of the images as per the class. And the next one is we are using a 3x3 subplot in order to plot every image from the class. So these are the images from each class from the training dataset. So here we are counting the number of images in each class. counting them, we are printing it in a data frame. So we are representing the number of images present in the each class in a part of pandas data frame. Now we are just this is just a visualizing the how many instances and how many images are present in the particular class, and we can see that pigmented benign canopies have the high number of images. Now the next one is augmenter library. So we are using the augmenter library for the process of data augmentation. This is generally used for the resizing of the image by modifying the existing ones. So the main use of the augmenter library is when the data set is imbalanced or small, the feature which is dominate the other feature. Means the one which has high scale will dominate the other one which has low scale. So it will perform tasks like rotating, flipping and zooming in order to address this issue. So here we are applying the augmenter for the training dataset, that is which we have designed in the first part. So we are using the rotate operation in the data augmentation, and that is p dot rotate probability of 0.7. That means that only 70% probability we have to take in order to process the data augmentation. And the next one, max left rotation is equals to 10, max right rotation is equals to 10. This refers that left rotation and right rotation limit must be equals to 10. And the next one, p dot sample 500 refers to we are generating the 500 new images by performing the data augmentation process.
Okay.
So we have performed the data augmentation and we have generated the new images. So this one is for counting the total number of images after generated by using the procedure of data augmentation. So we got around 4,500 new images. And now we are creating the training dataset with the image processing. So we are taking the training dataset and we are splitting it into the training set and the validation set. And the validation split is 0.2, that is 20% of the data is taken for the validation. And the subset is equals to training, means the training phase will be taken as a subset for the data. And we are creating a training subset by using this number of files. And similarly, as we have created the training dataset, we will be creating the validation dataset. And now we are optimizing the dataset using the features like caching, prefetching, shuffle and also auto-tune. So caching refers to once the data is loaded and it will automatically stores it in the memory. And the next one, shuffle of 1000. This refers to it will randomly shuffle thousands of images without the images not required to memorize the order. And the next one is auto-tune. This will automatically load the images in advance in order to prevent the bottlenecks. And the next one is prefetch. It will automatically assist the number of processes to be executed in the training phase. These optimization techniques will help us to minimize the time and also decrease the parameters, and it will help for the accurate predictions. So here comes the building of the CNN model. So here for the first step for the CNN model architecture is rescaling. So we are rescaling the input image from 0, 255 to the range of 0, 1. And after this we are taking the convolutional layer. In this convolutional layer we will be performing the operation of convolution. So where the result will be transferred into the next input layer. So the pixel values will be converted into a single value in the convolutional layer. And the next one is pooling. So pooling we will be using in order to reduce the dimensions of the feature map. It will be helpful for the decreasing the number of parameters and also the computational cost for the training phase. And the next one is dropout layer. So dropout layer will randomly assign the input values 0, and also it will calculate the frequency rate at each step of the network. This will lead to decrease the problem of overfitting of the model. And the next one is flattening layer. So flattening layer will convert the input images into the one-dimensional array and it will transfer it into the next layer. And the next one is dense layer. So dense layer will present at the depth of a neural framework. This will be able to get the information from all the neurons that are present in the network. And the next is we are using two activation functions, that is ReLU, that is rectifier linear unit. It will output the positive value if the input is positive, and if the input is negative it will output as 0. The main use of ReLU function in this model is it will solve the problem of vanishing gradient. And the next one is softmax. So softmax we are using mostly for the multinomial probability distribution. It will gives us the probability value with a range of 0, 1, and the sum of probability must be equals to 1. So after performing this, we will be getting the output shape and the parameters. So this is just visualizing the flowchart of complete what are the layers we are using in the CNN model architecture, and what are their input shape and the output shapes. And we are storing this in the model plot PNG file. And now we are compiling the CNN model by setting up the callbacks. So the callbacks we mostly used are the checkpoints and the early stopping. So we are using the optimizer Adam, that is mostly used common optimizer for the deep learning model, and the categorical cross entropy for multi-class classification. So next one is training the CNN model. So we are training the CNN model by keeping the epochs of 20, and we are using the training dataset and also the validation dataset, and the callbacks are checkpoints and early stop. So the early stop will make sure that if the performance is not improving, it stops the training process, and the checkpoint will save the model at its best phase before it going to the further process. So here we are just visualizing the model performance, that is we are creating the two graphs, that is between the model accuracy of training and validation, and also the model loss for both training and validation. So I have taken an image from the folder, and we are testing the model on the class. So first we will be gathering all the probability scores, and the one which have the high probability score which will be taken into the account. So the predicted class will be printed. So in this way we can use the CNN model for the skin cancer.